TypeScript provides a set of utility types which we can use to create a type which is based on some other type, and this new type will be transformed in some way. Each of these utility types provides a transformation which we can apply to one of our types. In this series, I would like to talk about each of these types one by one. Let's start with partial. Partial is a generic type which takes one generic type parameter, t, which is an interface. Let's say we have interface A with two required properties, x and y. If we apply partial to this interface, we get a new type with all the properties from the interface A optional. Let me show you an example. Let's create an interface called Starship. It has a name and one more property, let's call it Enable Hyperjump, which is a boolean. Notice that both properties are required. Now I would like to create a function that allows the developer to update some property of the Starship object, like only the name or only the Enable Hyperjump property. So let's go ahead and type the function name. Let's call it update Starship. This function should take two parameters. The first one is the ID of the Starship. Let's say it's a number. And the second parameter is the object with Starship properties that we would like to update. Let's describe it as Starship for now. Now let's try to use this function to update only the name of a Starship. So let's update Starship with ID 1 and update its name to Explorer. Now we have an error because Starship that we described in here should have two properties. Two required properties. But in here we provided a Starship object with one property. We didn't provide a second required property. So in order to fix this error right now, we have to provide the second property. And now our Starship object is complete. But what if I wanted to update only the name? For this, I would describe the Starship object in our function as partial Starship. Meaning that the Starship object is of Starship type, but all the properties of the Starship type become optional in this case. And now our function works with any properties that we would like to update. We've got the required type. It's again a generic type which takes one generic type parameter, which should be an interface. Let's say we have interface A with two properties which are optional. When we apply the required type to interface A, we get a new type with all the properties of interface A, and the properties that were optional become required. Readonly. Readonly takes one generic type parameter, which should be an interface. And here again we've got interface A with two required properties, x and y. When we apply read-only to A, we get a new type with all the properties of A being read-only, meaning that when we create an object that is described by this read-only A type, we can't overwrite its properties. So if the property x or y is set, we won't be able to overwrite it. The record type. Quite frequently in programming we create maps. These are objects where we store values under some keys. Like in here, for example, we've got an object where we store the quantity of a fruit. So in here we've got 4 keys. We've got apples and oranges, and for the values we've got the quantities 10 and 20. So we've got 10 apples and 20 oranges. And in order to describe such a map in TypeScript, we can use the record type. which is a generic type which takes two generic type parameters. The first one is the type of the key, which in this case is a string, because apples and oranges keys are represented by a string, and for the value we specify the number type, because the quantities are numbers. Let me show you another example. In here, I would like to create a map of starships, where I will store each starship under its name. So let's create a map called starships. And let's use the record type to describe it. For the keys I will use strings, the starship names, and for the values I will use the starship objects. Okay. Now let's create our first starship, Explorer 1, and map it to the starship object that is related to Explorer 1. It's called Explorer 1, where hyperjump is enabled. Let's create one more, Explorer 2. Let's disable hyperjump in here. Okay, so this is how we can easily describe a map in TypeScript. The pick type. Pick allows us to create a new type based on some other type, with only the properties from the original type that we would like to have in the new type. And here we have interface A with three properties X, Y, and Z. If we apply pick to our interface A, and in here I would like to pick only the property X and Z, we will get a new type with only the properties that we picked in here. Let me show you an example. In here we've got the starship interface, and I would like to create a new type based on this interface with only the name property. So I do the following. And here I type from starship interface, I would like to pick only the name property. And for the result I get a new type with only the name property from the starship. Now let's talk about the omit type. It's opposite to pick. We have interface A again with three properties X, Y, and Z. In this case, I would like to omit some properties instead of picking them. So in here I omit property X and Z. And for the result I get a new type with all the properties that I did not omit in here. And in our case it's only property Y. Let me show you an example again. In here I would like to create a new type based on the starship interface, omitting the name of a starship. So in here I type omit from starship the name. And for the result I get a new type with only the enable hyperjump property in this case. So basically I get a new type with all the properties that I did not omit. Okay, let's talk about the exclude type. Exclude type allows us to subtract one union type U from another one T. Let's say we have type A, which is a union type that consists of string, an array of strings, or undefined. And we would like to have a new type with undefined excluded. So we do the following. From type A, we exclude the type undefined. And for the result, we get the part of type A that doesn't have undefined, which is string or an array of strings. Now let me show you an example. Let's say we have a restaurant with two visitors, John and Jane. And we would like to serve each of them a drink. So let's create a type to describe the available drinks. Let's say it's coffee, tea, or orange juice, or lemonade. Okay. Now let's serve a drink for John. John doesn't have a preference, so let's serve him any drink out of the available drinks we have. Let's create a variable for the drink. I'll call it John's drink. And I will describe it simply as available drinks. And now I can serve him, let's say, a coffee. Okay, now let's serve a drink for Jane. Jane has some preferences. So let's create a type to describe the drinks which Jane doesn't like. Okay, and Jane doesn't like coffee. And let's say orange juice. So we shouldn't serve her these drinks. Now let's create a variable to store the Jane's drink. And now we should describe the Jane's drink as available drinks minus the drinks she doesn't like. So we can use exclude to exclude the drinks she doesn't like from available drinks. So from available drinks, we exclude the drinks that Jane doesn't like. And for the resulting type, we get the list of drinks Jane can drink, like the tea and lemonade. So the drinks that she doesn't like, coffee or orange juice, have been subtracted from the available drinks type. And now we, for example, cannot serve her a coffee. We will get a TypeScript error. Oh, I should have used the Jane's drink variable. Okay, so we cannot serve her a coffee because we get a TypeScript error. So let's serve something that she would like to drink, let's say a tea, okay? So this is how we can use the exclude type. Now let's talk about extract. Extract is opposite to exclude. Let's describe the drinks that Jane likes. Drinks Jane likes. And she likes tea, lemonade, and let's say mojito. This is the type that is not available in our drinks list. Okay, now let's describe the Jane's drink using extract. To extract out of available drinks only the drinks Jane likes. So we use extract. From available drinks, we extract the drinks Jane likes. So out of this list, we extract only the tea, lemonade, and mojito. But because mojito is not in the available drinks list, it will not be extracted. So for the result, we get Jane's drink described as tea or lemonade. So this is how we can use the extract type. Now let's talk about the non-nullable type. It takes one generic type parameter t, which should be a union type like the type A, which is a union type of string, array of strings, null, and undefined. Now I would like to create a type that is exactly as type A, but without null and undefined. For this, I apply the non-nullable type to the type A, and for the result, I get the part of A without null and undefined. Let me show you an example. Let's say we have an interface called Starship Properties. In here we have the color property, which is optional and can be either blue, red, or green. Next, I would like to create a function that will paint some starship into one of these available colors. So let's call this function paint starship. Let's take the starship ID and the color we would like to paint this starship into. Let's describe the color as the type of the property color. So we type starship properties, and in square brackets we type the color property. Now, because the color property in here is optional, we can call the paint starship function with undefined for the color. And this would work now, but I don't want to paint a starship into an undefined color. So I would like to make sure that the developer who uses the paint starship function won't be able to use undefined or null for the color. So I would use the non-nullable type to accomplish this. And now the developer is still able to assign undefined to the color. What is happening here? Well, by default, TypeScript allows us to assign null and undefined to any type. If we create a variable, let's call it a, and say it should be a string, we can assign null or undefined to it. So, to make sure that we can't assign null or undefined to a type that doesn't explicitly say that it can be undefined or null, we should enable the option called strict null checks. And to enable it in this project, we can use the tsconfig JSON. And inside we define the compiler options and enable the strict null checks option. Okay. Now the editor uses this tsconfig JSON to compile the TypeScript file in here. And we cannot assign null to a because a is exactly a string and doesn't allow null or undefined. And also we cannot assign undefined because color is non-nullable, meaning that it cannot be null because we removed the possibility of null or undefined from this type, from the color property type. So we have to specify the color exactly, blue, green or red. Now let's talk about the return type type. It takes one generic type parameter t, which is a type definition of a function. In here we've got the function called hello world, which returns a string. Next, we try to extract the return type of this function. In here we use the typeOf operator to get the type signature of this function, because we cannot provide the function itself as the generic type parameter. We should provide the function's type. Let me show you an example. In here we've got the paint starship function from the previous example. Let's say on success this function returns an object with the ID and the color properties. Now let's try to extract the type of the return value of this function. Let's name this type paint starship return. We apply the return type to the type signature of the paint starship function. And to extract the function's type, we use the typeOf operator on the paint starship function. And for the result, we get the following type: an object with ID and color properties. Let's talk about the instance type. It takes one type parameter t, which should be the type of the static side of a class. We have a simple class car with public property name, public method drive, a simple constructor, and a static method called buildCar. Next, we try to extract the instance type out of the class car. For this, we use the instance type with the statement typeOf car. We use typeOf and not car directly to get the type of the static side of the car class. We use typeOf because the instance type expects the type of the static side. Finally, as the result of this statement, we get the car, which doesn't make sense in this case, because why not use car directly without this long line of code? Well, in this case, the instance type is useless, but it can be very useful in other situations, like for example with the mix-in pattern. Let me show you an example. Let's create the car class. And the class user. It also has constructor with the name property. Let's say both of these classes are entities that we store in the database. So I would like to add a functionality to be able to delete these entities from the database. For this, let's add, let's say, the delete property, which is a boolean. We set it when the entity is deleted, and the delete function. Also, let's call the property deleted. Okay. So in this function, we would delete the entity. Then we would do the same for the user. Basically, the functionality will be repeated. So in here, we can use the mix-in pattern to share this functionality between the car and the user. So let's do this. I'm creating a function called deletable. As the argument, it takes the base class, which in our case would be the car and the user classes. Let's call the argument base class or just base. We should describe this argument. For this, let's make the deletable function generic, because we would like to accept any class. Let's call the generic type parameter base class and describe base as base class. Now we need to make sure that the base class type is actually a class that can be constructed or instantiated. So let's create a helper type. Let's call it constructible. And in here we define a constructor function by appending the new keyword to the function description. This function takes some arguments, like it can be any argument, and returns the instance of the class it's constructing. Let's call this type class instance. But we can't get this type out of nowhere, so we need to define it as a generic type parameter in here. So let's call this type class instance and return it from the constructor function. Okay, now that we have the type which describes any constructible class, we can use this type to constrain the base class to make sure that base class is actually a class that we can construct. For this, we use the extends keyword, and then we type constructible, and as the generic type parameter as instance, let's provide like an empty object, okay? Now, from this function, we should return a new class. Let's use an anonymous class, which extends our base class, this one. And in this class, we add the delete functionality. Now our anonymous class has all the features of the base class because it extends it, and also the delete functionality. So now let's remove the delete functionality from both car and user and use the deletable mixin function to make car and user classes deletable. For this I type const. First let's make the car deletable. Okay, let's make the user deletable as well. So now we have the deletable car and the deletable user classes. Let's say we would like to add another class, the profile, which will hold the data about the user and their car. Profile class will have property user, which should hold the instance of the user class. How do we describe that the user property is an instance of the deletable user class? If deletable user was defined as a normal class, like the class user or class car, we could describe the instance like this: deletable user. But in this case, we create a class and assign it to the deletable user variable. So it's not a type, it's a variable. So we cannot use a variable in place of the type. So in order to get the instance type of the deletable user variable, we do the following. Let's call this type deletable user instance. Then we say instance type, and we provide the type of the static side of the deletable user class. For this we type of deletable user. And now we can use this deletable user instance type to describe the user instance in here. We should do the same with the deletable car instance type. Okay. Finally, let's instantiate the profile. And assign the instance of a user. Oh, not user, it expects the deletable user instance. So we type new deletable user. And deletable user expects a name, so let's name the user John. And we create the car for John. Let's call the car Ferrari. Okay, that's it. This is one of the most popular use cases for the instance type. Finally, let's talk about ThisType. ThisType doesn't transform one type into another as the other utility types do. ThisType acts as a marker that allows us to specify the type of this keyword in an object. Let's see the first example. In here we have interface myObject that has one method say hello, and we've got another interface myObjectThis, which we use to describe the this keyword of our object, and this keyword should have the hello world method which returns a string. Then we create myObject object and describe this object using the myObject interface we defined in here. Then we use this type marker to describe the this keyword using the myObjectThis interface. Why would we describe the this keyword apart from the main object? Well, maybe we would like to set the context of this later in our program. Let's check how. Let's open this code in an editor. In here we've got the same code that I showed you on the slide. This is the object we have created. Let's use the bind method on the sayHello method to set the context of this. Let's set this to the object that has the hello world method. Okay. Finally, let's call sayHello. Let's log it. Now let's compile the file and run the JS that we've got. And we've got the hello world string that we set in here. Now let's check the example from the TypeScript handbook. In here, I have opened the ThisType section. The handbook says that we have to compile this code with no implicit this option, otherwise this type won't work. Let's copy this code into the editor. Okay, so what we've got in here? First, we have the definition of the type called object descriptor, which is a generic type which takes two generic type parameters, d and m. This type describes an object with two properties, data and methods. The type of data is d, and the type of methods is m, and this type with d and m. So it's an intersection of d and m. So basically what this says is the data property should be an object of type d, and methods property should be an object of type m. And the this keyword in methods should be set to an object that has a shape of both d and m combined. Then we've got the function called makeObject. It takes the same two generic type parameters, d and m. It takes the desc argument, which is described as object descriptor, this one, with the d and m parameters from the function's generic type parameters. Finally, this function returns the intersection of d and m. So it returns the object with the properties and methods of both d and m combined. Now let's see what this function does. It creates the data object. If the data property is set on the desc object, we take the data from the desk, otherwise we take an empty object. We do the same with the methods. Finally, this function returns a new object with all the properties of data and methods objects. Finally, we tell TypeScript that the return value has type of d and m combined. Okay, later on, we create an object using this makeObject function. We set the data to an object which has two properties x and y, and the methods object is set to an object with the moveBy method. From here, TypeScript is able to infer the types of d and m. It infers the type of the data object as d and the type, the structure of the methods object as m. Finally, it is able to infer the type of this object, since the object descriptor type describes the methods object as m, which is the type in here, and it uses the ThisType marker to set the this keyword to the intersection of d and m. So it's the intersection of the data object and methods object. And finally, this has the type, the structure of data object with X and Y, and the methods object with the moveBy method. TypeScript was able to infer all of this through the definitions above, through these definitions. Finally, for the ThisType to work, please make sure that the option called No Implicit This is enabled. Okay, that's it. Thanks for watching. If you liked the video, please click the like button. Have a nice day.